Hi everyone, so welcome to GATE Academy. So this is our next class of your chemical engineering thermodynamics. So आपको याद होगा लास्ट क्लास में हमने स्टार्ट किया था राइट, प्रॉपर्टी रिलेशंस फॉर आइडियल गैस. उसमें हमने कांस्टेंट वॉल्यूम सिस्टम का खत्म किया था राइट. सो दैट इज वी हैव स्टार्टेड विद कांस्टेंट वॉल्यूम सिस्टम एंड आपको याद होगा हमने ये स्टार्ट किया था दैट इज फॉर एनी चेंज ऑफ स्टेट फॉर एन आइडियल गैस आपका du होगा cv/dt, आपका dh होगा cp/dt. और इसके बेसिस पे हमने एक प्रीवियस ईयर गेट प्रॉब्लम भी सॉल्व किया था राइट. आई होप यू रिमेंबर. सो नाउ वी विल स्टार्ट विद व्हाट द रिमेनिंग प्रोसेसेस राइट. सो विद इन टुडेज क्लास हम पूरा टोटल प्रॉब्लम्स मतलब टोटल प्रोसेस हम कंप्लीट करने वाला है. सो कांस्टेंट वॉल्यूम इज ऑलरेडी डन. ठीक है, आपको याद होगा कांस्टेंट वॉल्यूम इज डन. सो द सेकंड टाइप ऑफ प्रोसेस ऑब्वियसली विल बी व्हाट योर आइसोबारिक प्रोसेस right, that is constant pressure process, that is your isobaric process. I hope आपको याद होगा right. So what is the speciality of isobaric process? Again pressure is constant. तो already हमने isobaric process पे most of the equations already we have written. ठीक है, the same thing I am going to start from the basics again. These things are already written by yourself, that is du. I am starting with again del q plus del w, that is हमारा जो first law equation से start किया मैंने. Again this du is equal to del q minus pdv. ये pdv मैंने इस साइड लाया, मतलब your internal energy change plus pdv for a constant volume system is equal to del q. तो du plus pdv क्या है आपका कांस्टेंट वॉल्यूम के केस में, दैट इज dh is equal to del q. यहाँ तक तो हमने ऑलरेडी सॉल्व किया है. तो अगर इसको इंटीग्रेट किया तो क्या आ जाएगा आपको, हीट ट्रांसफर ड्यूरिंग प्रोसेस 1 to 2 is equal to इंटीग्रेशन ऑफ dh, दैट विल बी डेल्टा h. whatever heat is transferred from 1 to 2 is equal to this. So आपको अगर लिखना है मतलब in terms of number of moles multiply करना है, आप लिख सकते हैं n into h2 minus h1. Why I am representing by small letter? Because specific meaning है right, मतलब जूल पर मोल पे होगा ये अगर h2 minus h1 है तो. Here I can say it is in joule right. I hope up to this is clear to you. अभी right यहाँ तक तो हमने already discuss किया हुआ है right. So these things have already done by us. Now what is the extra thing right, because हमारा एक और equation है like your constant volume, that is for constant pressure processes right. That is if it is an ideal gas, for any processes for an ideal gas right. जो भी आइडियल गैस के प्रोसेसेस होगा, इफ इट इज कांस्टेंट वॉल्यूम प्रेशर, एडियाबैटिक, आइसोथर्मल, डजंट मैटर, एवरी प्रोसेस फॉर एन आइडियल गैस योर DH इज ऑलवेज Cp dt. तो आपका Q12 क्या होगा, Cp/dt भी लिख सकते हैं ना आप. सो इट विल बी इक्वल टू व्हाट, सो योर हीट ट्रांसफर ड्यूरिंग कांस्टेंट प्रेशर प्रोसेस इज इक्वल टू, वी हैव द इक्वेशन डेल्टा H. So you have the equation what, Cp into T2 minus T1. ठीक है, if the Cp unit is in joule per mole Kelvin, you can multiply by number of moles. Simple, right? So these are the equations for what, your isobaric system, right? So these are the equations for isobaric system. Most of the cases in GATE, they will give you it is a constant pressure process. If they give you it is a constant pressure process, you can do the remaining. ठीक है, सिंपल है ना. Now यहाँ तक तो ठीक है, हमने क्या क्या कैलकुलेट किया है. We know how to calculate enthalpy, you know how to calculate heat transfer, right? We are interested in calculation of what is the work done in an isobaric process. कैसे कैलकुलेट करेंगे, सिंपल है ना right. That is very simple. आपको पता है what is the equation for work, del W is equal to minus PdV. तो आपको इसको इंटीग्रेट करना चाहिए राइट. फॉर कैलकुलेटिंग वर्क ट्रांसफर फॉर द प्रोसेस 1 to 2, यू आर इंटीग्रेटिंग दिस प्रोसेस फ्रॉम 1 to 2 PdV. कैसे करेंगे, इफ इट इज अ कांस्टेंट प्रेशर प्रोसेस, P हम आउटसाइड ले सकते हैं ना राइट. यू कैन टेक द P आउटसाइड बिकॉज इट इज अ कांस्टेंट प्रेशर प्रोसेस. सो टेक द P आउटसाइड. सो इट विल बी, it is equal to minus P into, what is the integration of dV, it will be V2 minus V1. So it will be P into V2 minus V1. So this is the first equation, P into V2 minus V1. very simple. ये अगर आपको graphically करना है, so I hope you remember what will be the PV diagram of constant pressure process. constant pressure process का PV diagram कैसे होगा, straight line, right? So this will be 1, 2. Area under the graph will be what? This area. What will be this area? That rectangular area. That is P into V2 minus V1. P into V2 minus V1. Same. Correct enough? Right. I hope you are able to find this. Clear? So these are the equations you have for what? Constant pressure process. Now, एक और equation हो सकता है. Why we are interested in more equation? क्यों मैं मतलब बार बार equations why I am writing? Because the simple reason is sometimes in the question आपको V2 V1 नहीं दिया होगा. Simple. ये भी हो सकता है. P नहीं दिया होगा. Right. So in that case also आपके पास equation होना चाहिए ना solve करने के लिए. So आपको ideal gas है तो you know P1 V1 is equal to NR T1. P2 V2 is equal to NR T2. Constant pressure process है तो PV1 is equal to nRT1, PV2 is equal to nRT1, P1, P2 same है ना. So what can I write for PV2? It is nRT2. So in case of this 1, 2, I can write minus of nR into T2 minus T1. In case आपके पास, right, they haven't given the value of pressure, volume, etc. If you have the value of two temperatures and you have the value of R, that is 8.314 and number of moles, आप ये value calculate कर सकते हैं. ठीक है, ये भी एक equation है. तो सारे equations आपको याद करना है, मतलब so that, right, अगर आपको याद नहीं है तो भी कोई problem नहीं, you should know how to derive it. Right, so if you know the derivation, it will be very simple, yeah. Right, so it's the meaning, right. So complete it. So that is your isobaric process. Clear? So complete the isobaric process, write all the things. So go through everything. Done. So this is your second process. That is your isobaric process. Clear? So everything is done for isobaric process. So go through the notebook. What are the things we have written for isobaric? So we have done constant volume and we have done constant pressure. So obviously your third process will be what? Isothermal. Clear? I am writing the third process, the most important process in your thermo 1 as far as gate is concerned is isothermal. क्योंकि आपका maximum questions जो है isothermal and adiabatic के ऊपर है. ठीक है? So now you can see here. What is the speciality of isothermal process? Temperature is constant. This is the first thing you need to understand. Temperature is constant. ठीक है? So your temperature is constant for isothermal process. I hope you understood this. So whatever we are doing is for ideal gases. So we can say what? PV is equal to nRT. Clear? PV is equal to nRT. So temperature is constant. So PV is equal to nRT, meaning is PV is equal to constant. So can I write for isothermal process PV equal to constant? ठीक है ना? So we are starting for ideal gases. Okay, remember we are starting for ideal gases. So first we are writing your equation for first law of thermodynamics. Du is equal to del Q plus del W. Clear? Starting with this, right? कोई problem नहीं ना? Right? We are starting with du is equal to this. लेकिन आपको पता है, for any change of state of ideal gas, your du is equal to what? Cv into dt. This is for what? For ideal gases. राइट मतलब आपको स्टेप्स याद रखना है, मतलब हाउ वी आर गोइंग स्टेप बाय स्टेप, राइट ईच स्टेप आपको याद रखना है. ठीक है? सो फॉर आइडियल गैस du cv dt, व्हाट विल बी dt फॉर isothermal प्रोसेस? 0. राइट, सिंस देयर इज नो टेम्परेचर चेंज, आपका dt क्या होगा? 0 होगा. राइट, सो सिंपल, सो dt इज 0, सो व्हाट विल बी योर du? du is 0. राइट, फॉर आइडियल गैस your internal energy change is equal to 0. So apply this in your first law equation. So you will be getting what? Del Q plus del W is equal to 0. right? Del Q plus del W is equal to 0, or we can say whatever heat transfer is equal to work, right? Or we can say del Q is equal to minus of minus PdV, it is PdV, right? Whatever heat transferred is equal to PdV in case of your आइसोथर्मल प्रोसेस, ठीक है ना? यहाँ तक तो ठीक है। तो लेकिन प्रॉब्लम क्या है, आपके पास तो है हीट ट्रांसफर का इक्वेशन तो आ गया, हीट ट्रांसफर इज इक्वल टू वर्क डन, लेकिन ये वैल्यू कैसे कैलकुलेट करेंगे हीट ट्रांसफर, राइट? सो यू नीड द आंसर, राइट? यू नीड हाउ मच हीट इज ट्रांसफर ड्यूरिंग एन आइसोथर्मल प्रोसेस। फॉर एग्जाम्पल, ठीक है, आइसोथर्मल कंप्रेशन ले लो, राइट? टेक एन एग्जाम्पल ऑफ आइसोथर्मल कंप्रेशन। तो आइसोथर्मल कंप्रेशन में क्या होता है, दैट इज यू हैव ए दिस वॉल्यूम, राइट, विद सम प्रेशर। अभी आपको इसको कंप्रेस करना है, राइट? यू आर ट्राइंग टू कंप्रेस इट, राइट? लेकिन कंप्रेस करना है तो आपको कुछ वर्क तो देना पड़ेगा ना, राइट? यू हैव टू गिव सम वर्क टू कंप्रेस दिस, राइट? इनिशियली दिस इज द पोजीशन, नाउ यू नीड टू कंप्रेस दिस टू दिस। उसके लिए यू हैव टू सप्लाई सम वर्क, राइट? सो यू नीड टू कैलकुलेट हाउ मच वर्क शुड बी गिव, right? How much work should we give? So you know for isothermal process, right? You know for isothermal process that work is equal to heat transfer, no problem. But why there is a heat transfer in an isothermal process during compression? क्योंकि जब भी हम compress करते हैं ना, whenever we compress, what happens to the temperature? Think, whenever we compress something, right? Whenever we compress something, our temperature goes up. Clear? So you can see here, this is our initial stage. Now we are compressing this to this volume. Now we are compressing this, right? So whenever we compress, what will happen to your temperature? Your temperature will go up, right? When you compress something, the temperature will go up. लेकिन हमें चाहिए isothermal compression, ठीक है ना? मतलब इनिशियली यहाँ पे इस सिस्टम पे आपका टेम्परेचर है 50 डिग्री सेल्सियस, लेकिन जब आप कंप्रेस करते हैं ना, क्या होता है, टेम्परेचर विल चेंज टू 75 डिग्री सेल्सियस। लेकिन हमें कौन सा कंप्रेशन चाहिए, हमें आइसोथर्मल कंप्रेशन चाहिए, सो दैट वी नीड टू रिलीज सम हीट टू आउटसाइड, वी नीड टू रिलीज सम हीट टू आउटसाइड, सो दैट दिस 75 विल टर्न इनटू 50 अगेन, राइट? सो व्हाटएवर there is an increase in temperature, right? Whatever is the temperature increase due to compression, that temperature should be reduced back to the initial value by releasing heat to outside, ठीक है? That is the reason for an isothermal compression you have an energy transfer or you have a heat transfer. That's why you have an energy loss or heat loss, ठीक है? So I hope you are able to understand this, right? Clear, right? Now those who are asking why there is a sign change, what is the problem here, right? Del Q is equal to minus del W. Why is like that, right? Because the simple thing you can see here, you are doing work on the system. If you are doing 100 joule work on the system, right? If you are doing 100 joule work on the system, according to this equation, what you are saying is, if you give 100 joule of work into the system, that is, if you give 100 joule of work into the system, if it is an isothermal compression, it will release 100 joule of heat to outside. Whatever work is given, right, that particular amount of heat will be rejected to the surrounding, right? So whatever, why are we rejecting? Because we need to keep the temperature constant. So you can see work done on the system, right? So this is the work done. Work done on the system is positive for us. Heat rejected to the system is negative for us. That's why there is a sign change. 100 is equal to minus 100. Clear? आपको समझ में आ गया ना? मतलब आपको कंप्रेस करना है. For example, for compression, we are doing work on the system. That work done on the system is 100 joule. राइट? सो टू कीप द टेम्परेचर कांस्टेंट, क्योंकि जब भी हम कंप्रेस करते हैं ना, आपका टेम्परेचर विल इंक्रीज, आपका टेम्परेचर ऊपर चले जाएगा. टू डिक्रीज दिस टेम्परेचर टू द इनिशियल और टू कीप द टेम्परेचर कांस्टेंट, आपका टेम्परेचर कांस्टेंट रखने के लिए हम एनर्जी बाहर छोड़ रहे हैं, मतलब वी आर लूजिंग द हीट सो दैट वी नीड टू कीप द टेम्परेचर कांस्टेंट. सो इस केस में आपका जितना भी वर्क दिया ना, उतना ट्रांसफर होगा आउटसाइड. दैट्स वाई Q is equal to minus W. लेकिन अपना जो हीट लॉस होगा हमेशा माइनस में लिखेंगे ना, minus 100 जूल. सो 100 जूल minus 100 जूल. दैट्स वाई देयर इज अ साइन डिफरेंस. राइट? क्लियर? आपको अब तक क्या तो पता है ना? राइट. आई होप अप टू दिस इज फाइन. क्लियर. नाउ अभी क्या चाहिए हमें? अभी हमें चाहिए वर्क के लिए इक्वेशन. राइट. अप टू दिस इज फाइन. ठीक है, यहां तक तो ओके है, लेकिन हमें तो इक्वेशन चाहिए ना वर्क के लिए. सो हाउ विल वी फाइंड इट? सो यू नो डेल डब्ल्यू इज इक्वल टू माइनस ऑफ पी डी वी. यहां तक तो पता ही है, लेकिन अभी इसको इंटीग्रेट करके आपको वर्क डन प्रोसेस फॉर द आइसोथर्मल प्रोसेस 1 to 2 फाइंड करना है. सो इंटीग्रेटेड फ्रॉम पी टू डी वी. लेकिन हाउ विल बी दिस इंटीग्रेशन? राइट. लास्ट कांस्टेंट प्रेशर में कोई प्रॉब्लम नहीं था. P बाहर ले लो, V2 माइनस V1, प्रॉब्लम इज सॉल्व. कांस्टेंट वॉल्यूम पे dV0 था, कोई प्रॉब्लम नहीं. लेकिन यहां पे प्रॉब्लम क्या है? प्रॉब्लम इज we need to write the pressure in terms of volume, right? We need to write the pressure in terms of volume. Now you can see here PV is equal to constant. So what will be P? P will be C divided by V, constant divided by V. Substitute here. So what will be work done for the first process? It will be minus, it's outside. I am writing P as C by V into dV. Take this C outside. So what will be work done? It will be minus C into integration of dV by V from 1 to 2. What will be the integration of dV by V? It will be work done for the system 1 to 2 will be minus C into ln V2 by V1. Right, so don't do anything with this minus, keep as it is. The remaining will be your answer, because this minus is for what? Our sign convention, right? No problem. Leave that minus there and write the answer. That's all. C ln V2 by V1. Clear? So this is the equation for what? Right? This is the equation for your work done in case of isothermal. Right? लेकिन problem क्या है? Problem is what is the value of C? Right? Value is C. Right? What is the value of C? So C के value कुछ भी हो सकता है यार. मतलब आपके क्वेश्चन के हिसाब से आप ये C के वैल्यू चेंज कर सकते हैं. मतलब आपका फाइनल इक्वेशन तो यही है, माइनस C इंटू एल एन वी टू वी वन. राइट. नहीं तो C इंटू एल एन वी टू बाई वी वन. लेकिन ये जो C के वैल्यू के हिसाब से, C का वैल्यू कैन बी डिफरेंट थिंग्स. राइट. सो आपके क्वेश्चन में जो भी गिवन वैल्यू है ना, उसके हिसाब से C को चेंज कर लो एंड फाइंड द आंसर. सिंपल. मतलब आप ये देख सकते हैं, व्हाट कैन बी द वैल्यू ऑफ C? C कैन बी, आई विल राइट इट हियर. ओके. C का वैल्यू क्या क्या हो सकता है? C का वैल्यू हो सकता है P1 V1. Can I write P1 V1 is equal to C? Same way I can write it as P2 V2 is also equal to C. So C का वैल्यू P1 V1 भी हो सकता है, P2 V2 भी हो सकता है. C के वैल्यू ये भी हो सकता है ना, nRT is also value of C. So by substituting these three value here, आपके पास 3 equations और आ गया. राइट. वर्क के लिए क्या क्या इक्वेशंस होंगे? आई कैन राइट इट. राइट. दैट इज वर्क डन फॉर आइसोथर्मल प्रोसेसेस P1 V1 into ln V2 by V1. What is the second equation? Second equation is P2 V2 into ln V2 by V1. एक और इक्वेशन आ सकता है. What is the third equation? Minus nRT into ln V2 by V1. 3 equations हो गया ना. Right, you have 3 equations now. That is 1, 2, 3. तो क्वेश्चन के हिसाब से आप एक क्वेश्चन को, मतलब आपके इक्वेशन को चेंज कर सकते हैं. फॉर एग्जाम्पल, अगर वो लोग दिया है V2 V1 P1 V1, ये इक्वेशन यूज कर लो. P2 V2 V1 V2, ये इक्वेशन यूज कर लो. अगर P1 V1 कुछ भी नहीं दिया तो वो इक्वेशन यूज कर सकते हैं. सेम वे जितने भी इक्वेशन में मैंने क्या सब्स्टिट्यूट किया है? V2 by V1 सब्स्टिट्यूट किया ना. अब अगर आपके पास V1 V2 दिया ही नहीं है क्वेश्चन में, इफ दे हैवंट गिवन द वैल्यू ऑफ V1 V2, व्हाट विल यू डू? यू हैव द इक्वेशन, राइट? P1 V1 is equal to P2 V2. So from this, what is V2 by V1? V2 by V1 is equal to P1 by P2. तो जितने भी इक्वेशंस मैंने डेवलप किया ना, हमने जितने भी इक्वेशन डिराइव किया है, इन एवरी इक्वेशन इंस्टेड ऑफ V2 by V1 you can substitute what? P1 by P2 and you will get 3 more equations again. Clear? So no need to remember any equation, just remember how to find C, L and V2 by V1. Clear? How to find C, L and V2 by V1. If you know C, L and V2 by V1, by substituting different value of C, you can get n number of equations. right? Minimum 1, 2, 3, 4, 5, 6 equations, 6 plus 3 again 9, right? So there are different equations you can write, because you can write P1 V1 into ln V2 by V1 1, P1 V1 into ln P1 by P2, 2 equations हो गया. Same way interchange it and you can write lot of equations. Clear? So importance is only this, you should be able to write this derivation completely. Clear? You should be able to write this derivation completely. So if you are able to write it, right, it is done. Right? So starting from this point, you should be able to write the entire derivation. Right? Clear? So go through this. I hope you are able to see everything here. So this is the end of your isothermal process. Clear? I hope everything is okay here. Right? Can I change this? Right? Can I rub this? So since we have completed the first 3 processes, right? First 3 processes done. Can we move to the third process? That is constant volume is done, constant pressure is done, isothermal is done. So obviously what will be the next? It will be adiabatic. Clear? What is the speciality of next process? It is your adiabatic process. Clear? Again, how to start this adiabatic process, right? How to start this adiabatic process again. Same thing. That is, what is the speciality of adiabatic process? That is, there is no heat transfer during adiabatic process, right? So there is no heat transfer during adiabatic process. So I will explain you with the same logic that I used in isothermal compression. मतलब अभी आप यहाँ पे देख लो adiabatic compression. राइट मैंने आपको आइसोथर्मल कंप्रेशन एक्सप्लेन किया ना, मतलब हमें टेम्परेचर कांस्टेंट रखना है. सिंस यू वांट टू कीप द टेम्परेचर कांस्टेंट, आप हीट बाहर रिलीज कर रहे हैं. लेकिन यहाँ पे क्या प्रॉब्लम होगा एडियाबैटिक कंप्रेशन में? आप बाहर हीट रिलीज कर नहीं सकते. यू कैन नॉट रिलीज द हीट टू आउटसाइड. Adiabatic compression, right? When you are compressing the system from this point to this point, right? When you are compressing this system, you cannot release heat because the system is insulated. ठीक है? So when the system is insulated, right? That is, your meaning is you cannot have heat transfer, right? You cannot have heat transfer. Heat cannot go out. So obviously क्या होगा? Whenever we increase pressure, your temperature भी increase होगा. You cannot keep the टेम्परेचर कांस्टेंट ड्यूरिंग एडियाबैटिक कंप्रेशन, क्योंकि हमें हीट ट्रांसफर अलाउ नहीं है. अगर हीट ट्रांसफर नहीं अलाउड है तो ऑटोमेटिकली अगर कंप्रेशन करने टाइम पे क्या होगा? योर टेम्परेचर विल गो अप, राइट? व्हेनेवर यू कंप्रेस एडियाबैटिकली योर टेम्परेचर विल गो अप. क्लियर? आई होप अप टू दिस इज फाइन. सो नाउ यू कैन सी व्हाट you can see adiabatic process. Q is equal to 0, right? Q is equal to 0. So adiabatic process equation, how will we represent an adiabatic process equation? That is PV power gamma is equal to constant. That we have learned in our 11th 12th, right? How adiabatic process PV power gamma is constant is our representation. Now what is gamma? You know gamma already, we have told it is our Cp divided by Cv, or adiabatic index we can say. It is Cp divided by Cv. Since always Cp is greater than Cv, right? Your value will be always greater than 1. Up to this is fine. तो अभी लिख लो, स्टार्ट कर लो. व्हाट वी आर गोइंग टू राइट, दैट इज du इज इक्वल टू व्हाट? योर du विल बी इक्वल टू डेल q प्लस डेल w. ठीक है? यहाँ पे क्या कैंसिल होगा? योर हीट ट्रांसफर विल बी 0, क्योंकि आपका वैल्यू ऑफ हीट ट्रांसफर इज 0 फॉर एन एडियाबैटिक. सो आपके पास है du इज इक्वल टू डेल w. यहां तक तो ठीक है, सबको पता है du इज इक्वल टू डेल w, राइट? तो यहाँ पे आप देख सकते हैं, अभी मैंने एक्सप्लेन किया था आपको, मतलब जब भी एडियाबैटिक कंप्रेशन होगा देयर विल बी नो हीट ट्रांसफर. हीट ट्रांसफर 0 होगा क्योंकि ये इंसुलेटेड है. तो जितने भी वर्क दे रहा है ना हम, वॉट एवर वर्क इनपुट वी गिव फॉर कंप्रेशन विल बी यूटिलाइज फॉर व्हाट? internal energy change, मतलब जितने भी आप work दे रहे हैं ना, whatever work you are giving for compression, that will be utilized to increase the temperature, right? So whatever internal energy change will be due to what? Work input, simple, right? Because there is no heat transfer. Clear? So I hope you are able to connect the dots, right? Whatever I am saying. Now du is equal to del W. लेकिन हम लोग तो आइडियल गैस के ऊपर डिस्कशन कर रहे हैं ना, लाइक वी आर डिस्कसिंग एवरीथिंग अबाउट आइडियल गैसेस. तो हमें पता है यू हैव वन मोर इक्वेशन फॉर आइडियल गैस, डी यू इज इक्वल टू सी वी डी टी फॉर आइडियल गैस. सो यू हैव एन इक्वेशन लाइक दिस. आपका इंटरनल एनर्जी चेंज और वर्क डन कैलकुलेट करना है आपको. अगर एडियाबैटिक के केस में इफ यू वांट टू कैलकुलेट द इंटरनल एनर्जी चेंज और वर्क डन फॉर आइडियल गैसेस, you have an EC equation CVDT by, right? So if they are asking adiabatic work done, first thing you need to check in the question, right? If they are asking adiabatic work done or internal energy change during adiabatic process, simple thing, first you need to check, do you know the value of CV? First thing you need to check, do you know the value of CV? Do you know the value of temperature T1 and T2? If you know both, simple, CV into T2 minus T1, your answer is ready, right? There is no need to go further. If you know CV and T2 and T1, problem is solved. That is the first thing you should always check about adiabatic process. लेकिन problem क्या होता है, right? If it is a 2-mark question, normally CV, T1, T2 will not be given. In that case, we need to go back and find our basic method, that is, you know, del W is equal to minus PdV. Clear? Del W is equal to minus PdV. Now how will you find the work transfer during an adiabatic process? You need to integrate this from PdV. So in the isothermal process we substituted P is equal to C by V. Same way here, what we will substitute? P is equal to C divided by V power gamma. So substitute and find the answer. That is, work for adiabatic process will be equal to C V power minus gamma into dV. Integrate it from V1 to V2. Integrate it from V1 to V2 and find the answer for adiabatic work done. That is, you have to do, right? So try to derive it. So derivation, do the derivation. Minus C I am taking outside. So what will be the integration of this? It will be V power minus gamma plus 1 divided by minus gamma plus 1. Clear? Right? That is V1 to V2. Multiply and find the answer. So can I write like this? 1, 2 is equal to C divided by 1 minus gamma multiplied by minus. I can write it as gamma minus 1. This one will be V2 power minus gamma plus 1 minus V1 power minus gamma plus 1. So you have to multiply with C with V2 and you have to multiply with C with V1. So when you multiply the C with V2, you can use what? P1 V1 gamma is also equal to P2 V2 gamma. It is also equal to C. When you are multiplying this C with V2, use P2 V2 power gamma, right? Use P2 V2 power gamma. So what will happen? C is P2 V2 power gamma, right? So V2 power minus gamma and V2 gamma will be cancelled out. So you will be getting work for adiabatic process will be P2 V2 minus P1 V1 divided by gamma minus 1. Right? Or if you want to keep that minus outside, that is this minus, if you want to keep it outside, it will become what? P1 V1 minus P2 V2 by gamma minus 1, no change. right? Any case you will be getting the same. So complete the answers. I hope up to this is fine. Right, so your final equation for work done for an adiabatic process is P2V2 minus P1V1 by gamma minus 1. Those who want to keep that minus outside, you can keep that minus outside and write P1V1 minus P2V2 by gamma minus 1. Both are same, right? Both will be same. Clear? Up to this is fine. So complete the derivation. Then now we have some changes in the equation. Clear? So I hope up to this is okay for adiabatic system. Clear? Now in the same equation we are going to make some changes, right? That is, we have more than one equation in the adiabatic system, right? So we are going to change some terms in this equation, that's you can see here. Up to this is okay. Finally we have reached this, right? In this equation what we are changing is, I'm going to take the P1V1 outside, okay? I'm going to take the P1V1 outside. So I'm saying work is equal to, if I take P1V1 outside, P1V1 divided by gamma minus 1. If I take it outside, it will become what? P2V2 divided by P1V1 minus 1. Is it okay? Up to this is fine. Now, you know, for ideal gases, what is P1V1 divided by P2V2 or P2V2 divided by P1V1? Because you know, P1V1 by T1 is equal to P2V2 by T2 for ideal gas. So what will be P2V2 divided by P1V1 for an ideal gas? Clear? It will be T2 divided by T1. So can I write this as work is equal to P1V1 divided by gamma minus 1. Here it is T2 by T1 minus 1. Clear? This is one equation. Now, if it is an ideal gas, can I write P1V1 is equal to, next step, P1V1 I am writing it as nRT1 divided by gamma minus 1 into T2 by T1 minus 1. P1V1 is equal to nRT1, right? Now, if I multiply with T1 inside, T1 got cancelled, and what will be the final equation? W is equal to nR into T2 minus T1 divided by gamma minus 1. So these are your major two equations for the adiabatic system. This is the first equation that you should remember, and this is the second equation you should remember. Clear? nR into T2 minus T1 divided by gamma minus 1. Some questions they may not give you P1, V1, P2, V2 may not be given. In that case, आपको ये equation use करना पड़ेगा. Clear? I hope up to this is fine. Clear? So complete up to this. Now, right, we have completed first two equations, right? We have done first two equations are okay. Now, what I am going to do is, you can see here, I have kept now three equations, okay? 1, 2, and this also I am keeping here as it is, right? 1, 2 is there and 3, right? Now, next, just 1 minute, close, okay? So up to this is fine. Next step, what I am going to do is, you know, for our closed system process, that is for adiabatic process, just now we have written your du is equal to del W, which is equal to, right? So what is this? This is equal to Cv into dt. So what is del W? Del W is minus P dV. So I can write minus P dV is equal to Cv dt. Clear? Minus P dV is Cv dt. So you know PV is equal to nRT. For if your number of moles is 1, if I consider 1 mole, what will be P? Can I write P is equal to RT by V? Clear? When your number of moles is 1, so can we write P is equal to RT by V? Substitute here, so it will be minus RT multiplied by dV by V will be equal to CV into dt. Take the CV this side, so this will be minus R divided by CV into dV by V is equal to dt by t. So check what are the things we have written so far. Clear? So what are the things we have written so far? du is equal to del w CV dt, that is minus p dv is equal to CV dt. Now instead of minus p, we are substituting RT by V. Now what is the next step, right? What is the next step? We all know Cp minus Cv is equal to R. You all know that, right? Cp minus Cv is equal to R. You need what? R by Cv here, right? So I am dividing by Cv throughout. So it will be Cp by Cv will be what? Gamma. Cv by Cv minus 1. R by Cv, you can keep it as R by Cv itself. Substitute here. It will be, I can write 1 minus gamma into dV by V is equal to dt by t. Do the integration. What you will be getting? It will be 1 minus gamma into ln V2 by V1 is equal to ln T2 by T1. Clear? Up to this is fine. So those who didn't understand, you can see here from first. du is equal to del w for what? This happens when your heat transfer is 0 for adiabatic process. That is equal to Cv dt. Clear? Up to that is fine, because ideal gas du is equal to Cv dt. Now in the same thing, you know del w is minus p dv, right? Your work done. Now minus p dv is equal to Cv dt. Instead of P for an ideal gas, you can write RT by V. PV is equal to nRT. From this RT by V you can substitute. Clear? So from this RT by V, I am taking that CV this side, T that side. So minus R by CV, dV by V, dt by T. Now you need an equation for R by CV in terms of gamma. So what I am doing, Cp minus Cv is equal to R. Divide throughout by Cv. So Cp by Cv is gamma minus 1. Equal to R by Cv. Clear? Up to this is okay. So substitute and finally you are getting this. Now so if I simplify this, can I write it as V1 by V2 whole power gamma minus 1 is equal to what? It will be P2 by P1. Sorry, not P2, it is T2 by T1. Instead of T2 by T1, you have a new equation. Now, for adiabatic process, P1 V1 gamma is equal to P2 V2 gamma. Right? P1 V1 gamma is equal to P2 V2 gamma. So, V1 by V2, what is V1 by V2? It will be P2 by P1 power 1 by gamma. Clear? So substitute this V1 by V2 here. So you will get a relation T2 by T1 is equal to, right? T2 by T1 is equal to, already you have a relation, that is V1 by V2 power gamma minus 1. At the same time, you will have one more relation. If I substitute V1 by V2 equal to P2 by P1, it will be P2 by P1 power gamma minus 1 by gamma. Clear? So this is the most important relation in adiabatic process. This is the most important relation you have in adiabatic process. That is the relation which shows, right? You can see T2 by T1, the temperature differences, right? So temperature ratio, you can see it is equal to V1 by V2 power gamma minus 1. And it is also equal to P2 by P1 power gamma minus 1 by gamma. Clear? Up to this is fine. Right, so those who are having confusion, just go back and rewind this particular video and you can see the remaining derivation. Right, once again check it. Clear? Up to this is fine. So now you can see. Now next step what I am going to do is, instead of T2 by T1 in this equation I am substituting this. So it will become P2 by P1 power gamma minus 1 by gamma minus 1. So this is our next equation, right? This is our next equation. Instead of P1 V1 I can write what, right? Instead of P1 V1 I can write nRT1 also, nRT1 gamma minus 1 multiplied by P2 by P1 power gamma minus 1 by gamma minus 1. Okay? So this is again another equation for your adiabatic system. So how many equations are there for your adiabatic system? First equation P2 V2 minus P1 V1 by gamma minus 1, एक equation हो गया. Second equation nRT2 minus T1 by gamma minus 1 हो गया. What is the next equation? You have this, right? And you have this. And again for same thing आपके पास एक और equation है. What was that? It was CV into T2 minus T1 simply, right? Because if you remember this, for adiabatic system what was the basic equation? du is equal to del q plus del w, but this del q is 0 for adiabatic system. So आपको अगर w calculate करना है, work reversible work for adiabatic system, you can use your ideal gas equation. What will be that? It is ncv dt. So integrate this. So it will be n into cv into t2 minus t1. So आपके पास अगर cv का value है तो there is, you require only one simple equation, right? This simple equation is enough to solve. If you don't have that, you have the remaining this much equations are there, right? So why we require this much equation? It's very simple, right? Very simple. Why we require this much equation? It is according to the given value, right? If they give you T2, T1 and CV, use this equation, completely khatam, right? The problem is over there. If you don't have the value of CV, use this equation because you have T1, T2, right? You can solve it. Clear? Can use this. If you have P1, V1, P2, V2, you can use this, right? Again, if you don't have temperature, you can use this equation. Clear? So according to the question, right? According to the question given, you have to solve it, right? You have to solve. So that is the end of your 4 processes, right? That is the end of your 4 major processes. That is, constant volume is there, constant pressure is there, isothermal, adiabatic, there is a polytropic process. That we will discuss in the next class. Why? Because we have done the first 4 processes and we will do some problems also, because I already told you, right? And that is, I want to do some problem in every lecture. Clear? So this is the end of our 4 derivation. So based on this 4 derivation, you can solve all the questions in GATE from this chapter. Clear? All the questions we can solve. It's very easy, right? If you remember everything. So the first step will be write the given value, then check which is the process, right? Then check what are the values given so that you can find the equation. Clear? It's very simple, right? So we'll see some problems in GATE, right? Then we will solve. Then we will discuss in the next class the polytropic process. So if you know this 4 derivation, constant volume, pressure, isothermal, adiabatic, 75% of the questions from Thermo 1 can be solvable, right? You can see that, right? If you don't have if you don't believe it, right? So what you can do is, after studying these 4, right, go back and try to solve all the questions from 2000 to 2021 in Thermo 1, right? Majority of the questions from this chapter can be solved. Clear? So we'll see some problems, right? So we'll see some problems in GATE. So go through all the derivation, and main thing after this class is, right, combining constant volume and today's 3 processes. You should know how to derive it, because if you don't remember one derivation also, right, if you don't remember one equation also, you should be able to derive it at the time of exam. Clear? That is the importance of explaining this much, right? That is how we are going to derive. So that's all. We will see some problems now. You can see this question, right? That is, 1 mole of methane is contained in a leak-proof piston. It's a GATE question, GATE 2011, I guess. Right, 1 mole of methane is contained in a leak-proof piston cylinder assembly at 8 bar and 1000 Kelvin. So write the given value. 1 mole of methane is contained in a leak-proof piston at 8 bar and 1000 Kelvin. Gas undergoes isothermal expansion to 4 bar under reversible condition, right? So reversible conditions is given and undergoes isothermal expansion is given, and methane can be considered as an ideal gas under these conditions. So they have given it is ideal also. Value of R is given. Heat transfer during the process, you need the answer in kilojoule, remember. Heat transfer during the process, you need the answer in kilojoule. Remember that as well, and you can see the options as well. Clear? So those who want to solve, pause this video and read the question carefully and solve. Clear? So I hope you can read the question. 1 mole of methane is there in a leak-proof piston, right? So if it is a piston cylinder assembly, always remember it is a closed system, okay? Piston cylinder assembly, it is a closed system. That is also done, right? So read the question, then we will see how to solve. So as I always say, write the given value, right? Always write the given value. 1 mole of methane is contained in a leak-proof piston. So whenever it is a piston cylinder assembly, right? Whenever it is a piston cylinder assembly, remember it's a closed system. So what are the given value? I will write the given values now. Number of moles is given, 1 mole, no problem, right? Now what are the things they have given? 1 mole of methane is contained in a leak-proof piston assembly at 8 bar and 1000 Kelvin. So P1, pressure is 8 bar and temperature T1 is 1000 Kelvin. So temperature and pressure is given at the state 1. The gas undergoes isothermal expansion. So this is a kind of question where they have specifically mentioned the process. So process is isothermal expansion. If it is an expansion, your pressure should decrease. Clear? Now, methane can be considered as an ideal gas under this condition. Value of R is given and they are asking heat transferred in kilojoules. What is the heat transferred? The answer should be in kilojoules. So option A is given, option B is given, option C is given, option D is given. So let me write the options. 11.52 kilojoules, 5.76 and 4.15, 5.76 and 4.15, and one more 2.38. Now, those who don't remember any equation, how to solve it, right? How to solve it? You know it is a closed system. So write the balance first. That is internal energy change is equal to del Q plus del W. First step. Okay, so it is an ideal gas, right? Ideal gas. So isothermal process ideal gas. You know du is Cv dt. So du will be equal to 0. So 0 is equal to del Q plus del W. तो आपको क्या calculate क्या करना है? You need to find the value of reversible heat transfer. So that will be equal to minus of work. Right. So what is the work done from 1 to 2? You need to find this. Easy. Right. So how to find it? How to find the work done? It's an easy question. That is, if you know the work equation, how to find it? That is integral of minus PdV from 1 to 2. Right. So P you can substitute for isothermal process. What is the speciality of P? It is constant divided by V. So it is minus C by V dV integration. So your reversible work done for an isothermal process is minus C into ln V2 by V1. This is the problem, right? This is the problem. Now, what are the values you have, right? What are the values you have? So depending upon the value, you need to find the answer. Clear? So it's an isothermal expansion process, right? It's an isothermal expansion process. So we can see here, what are the things given? Gas undergoes isothermal expansion to 4 bar, right? Isothermal expansion to 4 bar. So the pressure P2 is 4 bar is given. Simple. Now, I told you, Instead of C you can substitute what? P1 V1, P2 V2, nahi to nRT1, you can substitute anything, right? So now the problem is which equation you should select. The equation should be selected that should include what? Your given value. So do you have V2 and V1? Do you have V2 and V1? No, we don't have V2 and V1. So instead of V2 and V1, I will substitute what? Instead of V2 V1, I can substitute what? P1 by P2. Because you know P1 V1 is equal to P2 V2 for isothermal process. So P1 by P2 is equal to V2 by V1. Simple. Now instead of C you can substitute either P1 V1, either P2 V2, nahi to nRT1. Clear? nRT, because you don't have V1 and V2, so use nRT. So it will be what? Minus nRT ln P2 by P1. All values are there. Number of moles is what? 1. So minus 1 into R is 8.314. Temperature is 1000 Kelvin into ln of what is pressure 1? Pressure 1 is 8 bar divided by pressure 2 is 4 bar. Solve and find the answer. So what will be the answer? I hope you can see here. ln 2 multiplied by 8.314 into 1000. Your answer will be almost 5.76 kilojoules. 1000 will be there, so convert into kilojoule क्योंकि आपका आंसर चाहिए किलोजूल पे, so your answer option will be B. Clear? So I hope you can understand how we are solving the questions. Done? I hope you have done this question as well. Clear? So what is the importance of equations? I hope you understood, right? So what is the importance of equations? That is, if you know the equation, right? If you know how to derive the equation, there is no need to remember anything, right? So the selection of equation is based on what? Your given values. Instead of C, you can substitute either nRT or you can substitute P1 V1 or P2 V2. Why I am not using V2 V1? Because you don't have the value of V2 V1. But you know, if you have P1, P2, T1, etc., you can find V1, no problem, right? It's okay, you can find it. But go for the easier method, right? So those who already remember the equation, no need to do this, okay? Directly you can start from here. Within 1 minute you can solve the problem. Clear? So it is about the practice, how much you are doing the practice or how much you are able to derive this, right? So what you can do after this class is, whenever you start thermodynamics, right? Whenever you start to revise thermodynamics, start from this. Don't start from open system, closed system, system boundary. Don't do that. Don't start from pure substances also, right? Because this is the most important topic. So this is our 7th lecture or something, right? So this is the first important topic. I am saying most important topic. So start from this, right? So how to start? Start from this and try to derive whenever you are sitting free or whenever you are doing something, right? So take a paper and do the derivation of constant volume, constant pressure, isothermal, and finally adiabatic. Do all the 4, right? So that without seeing the book or without remembering anything at any time, you should be able to derive these 4, right? And if you have any confusion, come back and we see this lecture. It's always there in the YouTube. Clear? So these 4 things are important. So whenever you start revising thermodynamics, always you should start with this 4 derivation. That is, at whatever time you should be able to remember this and solve this. Clear? I hope you understood. So go back and check the derivation. So from the next class, right, for the next class, what I recommend is try solve all question in thermodynamics 1 based on this. Clear? So we will be solving some questions in class as well. So go to the previous year questions in your GATE Academy book and solve all the questions, right? You should be able to solve all the questions, right? So if you are not able to solve any question, right, you can send me in so that I will send the solution, or I will do it in the class itself. I will explain it in the video. Clear? So I hope up to this is fine. Right, that's all. So for the next lecture, we will again start the polytropic process and the remaining problems. Right, there are a lot of problems in GATE. Right, so free expansion is also another topic remaining in this chapter. That also we will discuss. Then we will start your open system. Clear? So solve all the questions. So remember to derive all the 4 and understand it. Right? At all time you should be able to do it. Thank you. That's all. Next class we will see.